All right, my powers of 10 experts, here we go. We are looking at a thinking question here about Dean. At 1 week, Dean had 10 pennies. Each week after, Dean increased the number of pennies by 10 times the previous week. During which week will Dean have, how do you read that number? Remember, you learned that this is the hundreds period, this is the thousands period, so this must be the millions. 1,000,000 pennies. So you can organize this in a table, and we can actually save ourselves a whole lot of writing by using powers of 10. And when we use powers of 10, we're really thinking about a multiple of 10 with all of these zeros and being able to write it in, it's called exponential form. So we can kind of break this down. Think of like standard form, word form, and expanded form. Very similar. So if I'm asking you for the power of 10, what I'm asking you for is it's the product of 10 multiplied by itself a certain amount of times. Really wordy. I'll show you here in a second. You can do exponential form, which means you are going to have the base and an exponent. Again, I'm going to show you here in a second. And here are those two coming to life. So this is right here, the multiplication expression. So I'm just going to say expression here. You could write that note down to yourself. So I want you to break down the value. It could be, okay, so 10 times 10. If I have 10 twice, let's label this one. This one's going to be where we're going to put the power. So the power is going to be 100 because that's what it equals, right? That's the 10 times 10. Now careful, a lot of people accidentally say 20. You guess it, they're accidentally adding. Then the exponential form is where we can kind of cheat having to write so many zeros. Because imagine, writing zeros this many times. 100's not bad. I get it. So exponential form is where we can take the base. So it's saying, okay, we have a 10, and then we use a itty-bitty little number called an exponent, and it always has to be in the top right-hand corner. That's where exponents always go. And the exponent's going to be how many times you have a 10. So if I have a 10 twice, I'm going to have my exponent twice. So let's even make a note that this is the base, the 10's the base, and the exponent is that little number right there. So that means we have 10 times 10, and that all equals 100. Notice I'm saying all of these things are equivalent to one another. They are equal. They're just different ways of writing them, especially when we have really large numbers, and you'll see that a lot in science. So let's answer Dean's question of getting to 1,000,000 pennies. And if it's increasing 10 times, now just to visualize what's happening here, is that then the second week we'd have 10 times 10, right? So that would be 100, and that's the power. So exponential would be 10 to the second power. If it goes up another 10 times, then we'd have 10 times 10 times 10, which is 3 zeros, placeholders, 1,000. So then what's the exponential form? 10 to the third power. You can also call this one 10 cubed, like for 3-dimensional. Let's write that note, cubed. And then this one is also, squared, because it's like 2-dimensional. You'll use this one with area. You'll use this one with volume, 3-dimensional things. All right, well, we're still not at 1,000,000. So then we're 10 times 10 times 10. Another week happens, so there we go. So we have 1, 2, 3, 4 zeros, right? Because of 4 tens, and then it's 10 to the 4th power. And then, still not there. Another week happens, 10 times 10 times 10. And then the 5th week is going to be 1, 2, 3, 4, 5. Now we're at 100,000, right? And that's 10 to the power of 5. And then 10 10, 10, 10. Run out of room here. 10. So we have 1, 2, 3, 4, 5, 6 on that 6th week. 1, 2, 3, 4, 5, 6. Right? So now we're at 1,000,000 pennies. So it's all those zeros, you could write 10 to the 6th power. So during what week will he have 1,000,000 pennies? It would be the 6th week. 6th week he would get there. So all kinds of like pattern work there, but really what we want to take away is how can we write these 3 different ways of our powers of 10? And then we're going to be utilizing that, and what is it doing to numbers, right? If we know that times 10 is going to move the digit to the left because it's getting bigger every single time we do another 10, if we use these to multiply by values, we're going to see that digit move and become bigger as well. And it's more than just having a 1. So turn over your paper and let's look at breaking some of these things down. So you are going to solve for these. Now you got to really pay attention to what they're asking for. So you're writing each power of 10 as a product. So in other words, the power is the same as the product. Let's go back over here and let's write product. Power product. So a product of these 10s. Basically, we want to know what that equals. So not like expanded form. So we know that 10 to the power of 7 means we're going to have, oh gosh, good golly, how many 10s are we going to have? 4, 5, 6, 7. No thank you, right? But that's not what they're asking for. That's the expanded form. So you really need to write the product. So what would that mean? Love erasable pens. So we'd have 1, 2, 3, 4, 5, 6, 7. This is where your elementary teachers might have been picky, and I do appreciate that they are like, you have to always put commas. Because 1, you can't read that number efficiently without them. You can read if it's in the thousands, if it goes into the millions. So I know I'm already in the millions, it's 10 million, right? All right, what about this next one? 1, 2, 3, 4, 5. How do you read that number? 100,000. Oh my gosh, 9? Who wants to do 9 zeros? 4, 5, 6, 7, 8, 9. I gotta double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, do you have 9? All right, now we're not even in the millions. We're in the billions. Millions to billions. So if we had 9 tens, that's what we're working with. Okay, well then 10 to the power of 3. Now we're a little bit more reasonable. Baby number now, 1,000. So that's the product. Okay, this is where it gets a little funky. So I'm going to highlight so you can kind of see they have this equivalency in 2 equal signs. So what they're saying is if I give you 100, right, and they did that for these, then I want some of the missing values. So some of the missing values listed here, and then some of them are given. I'm going to highlight to show you what you're actually looking for. So in this next part, they have, so it's the product, it's the expanded, and then what's missing would be the exponential form, right? So then if I give you 10, what's the like expanded, what's the multiplication expression, and what's the exponential? And then same thing with these, that if I color code this for you, help you out in seeing what's missing here. You can always flip back your paper to the other side and be like, wait, what piece do I still need? So if I give you this, can you fill in what different other forms are missing? So exponential form means we have that base and then we have the exponent. So 10 to the power of 2 or 10 squared. Now here's an interesting one. how many 10s do we have? Well, just 10. None are going to be multiplied by each other, right? And then what would that be as an exponent? How many 10s do you have? Here we had 2. If we have 1, the exponent's just 1. And then if we count the zeros, as you've seen that pattern, we have 6, right? So 10 times 10 times 10 times 10. Losing track. 1, 2, 3, 4, 5, 6. And then that means we have 10 to the power of 6. Right? So then here, oh, those commas help because then I know I have 6, I have 8. Oh, I'm jumping one. Now I just have 5 for this one actually. 1, 2, 3, 4, 5. And this is mega change in a value, right? 1, 2, 3, 4, 5. And then so I'd have 5 or 10 to the 5th power. Can't mix up the exponent and the base. And it changes how you read it. So, and careful, if I wrote this 5 any bigger, it would totally look like a 105. My exponent has to be smaller, so I know it's supposed to be an exponent. And here we are. Now we're at 6, 7, 8. I need 8. Oh, goodness. We get it, right? 5, 1, 2, 3, 4, 5, 6, 7. All right, I think I have 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 10s. So we have 10 to the 8th power. Okay? All right, well, why are we doing this? With all these 10s. But here's where it comes into play. So actually multiplying numbers by these larger values and how it's changing it. And this is just a stepping stone to when we get to decimals too, and how it's going to be changing. There's nothing more mind-boggling than someone getting this type of problem and going, oh, I have to multiply all of these by 0. And you go 0, 0, 0, 0, 0, 0, 0. And then you go 0, 0, 7, 3, 2. Like, our mental ability is way beyond that. If we really know what powers of 10 means and what's happening, we don't need to do this. This is a big no-no. Like, you're capable of using, mental math and showing your thinking. This is not necessarily just kind of robotic, like, must multiply all these zeros. Come on. If you see these 2 zeros, you know you just multiplied by 10 to the power of what? If there's 2 zeros, how many 10s is that? Well, the thinking behind that, you should think is 10 times 10. And that means it would be 10 squared, right? And then, same thing here. If I have 3 zeros, I have 10 to the power of 3. Because that's how many 10s? 10 times 10 times 10. That's my thinking going on, right? And then, ooh, even easier. We have 4. 10 to the 4th power. I don't know why a blank's not there, but it mentally is. We are doing 10 to what power? Just 1 0, so 1st power. You really could just do 10 too, right? You wouldn't need even a power for that one. So now you're going to solve these equations if it is 10 to the 2nd power. So these are whole numbers. This trick works where you can just count the zeros and put them on. But really what's happening are these digits are moving place values and becoming larger, right? So that is a times 10, and that is a times 10, which is the same thing as 10 squared, or 10 to the 2nd power. So we can just go, all right, I have a 45 and 2 zeros. Now here's where I might trick you. I hope I don't. It's when the number already has a placeholder 0 in it. So I still have to have the 70, right? And then the 2 zeros. A lot of people accidentally put 700 because you'll just count, oh, the answer just has to have 2 zeros. But you have to have what you originally started with. And then because this is 10 to the 3rd power, how How many tens is that? 1, 2, 3 tens. So it moved that 4, 1, and the 7 over to that next place value. So then 27 becomes 270,000. 9, 1, 2, 3, 4, 5. 900,000. And then 321 becomes 32,100. So we're changing the value of these digits by multiplying by 10. We don't have to actually multiply them if we know that digits move when we multiply them by 10, which we already know. Okay? All right, you are ready to move on and practice.